Okay, so welcome everybody to today's workshop, which is part one of the building a full stack application from scratch. The topic of today is basically this app. So this is the code repository. It's called Just Jot It. So this is something I wrote. You will find that I did my best to have this as well documented as possible. So all the code has a lot of comments that try to explain everything. So if you get stuck, just follow the comments. The app you're going to be building is linked already here, so you can open it at this URL, and it's going to look a bit like this. So you open the app, you're greeted with this front end like welcome, just please log in. You can log in, create an account. I will just use the pre-made account I already have for the sake of brevity, and basically it looks a bit like this. So it's just a very simple note keeping app, so I can create new notes, I can do a test title and a test node, and then create the node, and I'll create it successfully, redirecting, and you can just basically edit nodes that you already created, go back to home and visualize nodes. You can delete nodes or just view the details by clicking on them. So this is the full app, like what you will build if you attend all three parts of this workshop. So one part's today, and the other two parts, as I mentioned, the next 2 days at the same time, by the way. So you feel free to RSVP if you're interested. But yeah, this is the final product. So today we will focus only on building the backend for this, the server-side code, the Node, Express, and Mongo code necessary for this to work. So we have quite a lot of work and ground to cover, to be honest, because it's a lot of code. So yeah, let's get started on this. And as I promised, we will be starting like on a blank slate. So this might be the finished project, but we will be building this like step by step and partially. As best as we can. So let's create a new folder. So here we'll name it or just jot it. Now let's open this with our editor. So let's click on open folder and select folder. There we go. So here's our blank new folder. Now there's a few things I like to have before I start any project. So the first is an ESLint configuration, which works if you have the ESLint VS Code extension. For those unfamiliar, it's basically a plugin that scans your JavaScript code for code quality inconsistencies. So it makes it super easy to write clean, maintainable JavaScript code. It's fantastic. Then I'm also going to enable two options in my VS Code installation. A quick question from... yes, you need to install this ESLint extension if you want to use ESLint. So you can just search for it in the extensions marketplace. So yeah, these are mine, I guess. Yeah, I like to just try to keep it simple, but I do have quite a few extensions here and there. So yeah, going back to this, I also need what we call a Git Ignore file. So our Git Ignore is so that when we commit this code into GitHub, we do not push any non-necessary files. So what I'm going to do is I'm going to go to gitignore.io to generate a git ignore for me because I'm too lazy to figure it out. So I'm going to type node, Visual Studio Code, and Mac in case I ever push this to a Mac machine. Just click on create, copy, and paste. There we go. So that's that. Then we also need, I'm going to enable one really handy VS Code feature. So I'm going to enable a feature called auto fix on save. So let me find that auto fix on save. There we go. So this is from the ESLint package. If it finds any errors that can be automatically fixed, it will fix them every time I save my file. So that's really handy, just so that I can keep my code tidy as I write it. And then last but not least, let's format on save is also another really nice feature of VS Code, which basically every time you save your file, it automatically formats it for you. So it indents it properly, it indents it using clean code, best quality practices. So yeah, really handy. And we're done. So that's our workspace. Now it's time to begin coding this from an NPM perspective. So we're going to open our VS Code terminal, which you can, I know the shortcuts, but you can always just type it out like toggle integrated terminal, and you can even see what shortcut that is. So just open your terminal and make sure to initialize this npm repository. So let's do npm init. You can add the .ys, but I like to just do enter every single time I get the prompts in case I need to modify something. So yeah, let's just say yes. All right, so there is our npm repository. Now, as far as dependencies, we're going to need quite a few things. So we're going to need, out of the box, npm install. So make sure we save them, because right now our package JSON is completely empty. So we want to add dependencies to this. So npm install save. We're going to need, of course, Express for the server-side code. We're going to need Mongoose to connect to MongoDB. We're going to need, let's add Morgan. Morgan's a very nice logger for Express. We're going to use Joy. Joy is fantastic for data validation. We're going to use Passport, of course, for authentication. So let's add Passport and all these Passport dependencies. So Passport JWT, Passport local, JSON Web Token, of course, because that's what we'll be using for validation. And Crypt.js for encrypting the passwords, because you never want to store the real password in the database. So yeah, I think that's about it. Oh, and .env, just in case we need to store environment variables instead of a .env file. So let's do the npm install. And while that is happening, let's start progress on this. So we're going to start by adding basically a folder where to put all our Node.js code. So I'm going to type app. App is like a folder name I like to use for all my server-side codes. And inside of app, I'm going to begin with my famous server.js file. So server.js is where all my Express code is going to live. And now I'm going to start coding that. But before I do, I want to basically all that commonly used stuff, I want to put it into a config file. So I'm going to build a config.js file. And this config.js file is basically like I'm going to store an object here that I can basically, I'm going to use my config on the entire project. So let me just paste my config here. And as you can see, it's just a bunch of values. And right now they don't really have much meaning, but they will soon enough. So I added a lot of useful information that I can just quickly update from my config, like my port. So here's the port where I'm going to start my server. I added, you can also type like the HTTP status codes directly, but I'm terrible at memorizing them. So I just wrote an object that has all of them with names. So it's easier for me to use. Like, oh, I just need to return bad request. Cool. I just use status codes .bad request instead of memorizing the 400, 41, 404, 500, 204, 201, 200. Yeah, you get the idea. And finally, we also basically, because I'm also pretty bad at remembering Mongo's URL, I'm just going to type it here. So here's my Mongo URL. Here's my test Mongo URL, which we'll be using the next unit of the course. And these two are for authentication. So that's set up. Now let's continue with our server. So here's our server.js. Now, as far as boilerplate we need, we're going to need a few dependencies. So we're going to need first our core, basically npm dependencies. So we're going to need Express for basically writing or routers. We're going to use Morgan to log Express requests. We're going to use Mongoose to connect to MongoDB, and we're going to use Passport to authenticate. If you have questions about any of these libraries, I always add a link. So feel free to visit the link to learn more, and that's something I would heavily advocate. Like, if you are confused, just read the documentation. It's usually fantastic and very well explained. Like, even Passports, for example, if you ever have trouble with Passport, they have a fantastic getting started guide, which guides you through building like a basic Express.js application, and step by step and in a really simple fashion. So you probably want to check this out as well. So yeah, let's move on. So far we're good. Now let's also import some of our config variables in case we need them. So here I import my port, I import my HTTP status codes because I will be using them probably, and also my Mongo URL to connect to MongoDB. Now that that's set up, let's basically start our Express server. So let's start our Express server, and once that's set up, we also want to basically implement some pieces of middleware. So we're going to use these 3 pieces of middleware. Now, for those unfamiliar, middleware, think of middleware like an interceptor function. So basically, every request you make to this server, this entire server, is first going to go through this middleware. So for example, all the requests I make to my Express server are first going to go through the Morgan middleware. Morgan is a logger. So basically Morgan is what allows you to basically see the requests being logged to the console. That's not Express doing it, it's Morgan. Express.json is something that we do so that when you make a request to the server and you send data in JSON format, this parses the JSON, because otherwise you will just see a string of a JavaScript object that you cannot use. So this is what parses that automatically for you. And then this is the probably most useful piece of middleware when we get to the front-end part, because right now we don't really have anything. But if you add this middleware, basically we can create a public folder, and any files we add on public, like, I don't know, let's do test.js. So any files, whoops, should be test.html. So test.html. So any files you put in public, if you try to make a request to your server, so let's say this server is running at localhost 8080. If you did localhost 8080/test.html, that will work just by magic. And well, not so much magic. Basically, the magic here is that you told Express to first check if any requests it receives, compare them against any of the files inside of public. And if they match, respond with the actual file. So it's really handy. That's it up. Now we are going to use this one extra nice and handy function, which is called basically also another piece of middleware. So the reason why I like to write this is so that if you make a request to a URL that you don't really have a request listener for, a request handler for, it just responds with a status code of not found, and it responds with a JSON of not found, instead of your Express server throwing an error because it doesn't know how to handle that request. So yeah, we're getting close to finishing our very basic Express.js server. So now it's time to actually start the server. Now this part is might be like the most complex part of this, so please bear with me. So let's just add our boilerplate right here. So here I'm exporting three things. So I am exporting the app, which we might not need to right now, but we will be needing this for testing during the next video. So we export app, we export start server as well. So basically we export start server because we also need the ability to start the server, and we export stop server. Now, as far as how to start the server, it's actually quite kind of easy. Basically, you just run this function, and the first thing it does is it returns a new promise. The reason why it returns a promise is because we want to be notified of when the server is done starting, because starting the server is not immediate. It takes time. So this all works via callbacks in a way. So we return a promise to notify when it's done. The first thing we do is we want to connect to MongoDB. So because our server relies on a database, so right now here you can see that I have my MongoDB installation running. I have my server on my other monitor, so it's running just fine. So that's running. I want to connect to it. So I'm going to basically store it in my MongoDB a variable. So I'm passing in a variable called testenv, so that if this is passed in as a true, basically, if this is true, then it runs on my test database. If not, it runs on my default database. The reason why you want to do this is so that if you run tests, it doesn't wipe out your entire actual database. So tests normally wipe out the entire database on each run. So you don't want to delete your actual data. That's why you do this. And then we actually connect to the database with mongoose.connect, as you can see here. So Mongoose tries to connect to the Mongo URL, and then if there is an error, then log the error to the console and reject the promise because it went wrong. Otherwise, if no error occurred, then we actually do app, which in this case, app, as you can see, is our Express app, and we run app.listen. So doing app.listen starts the Express.js server, and you pass in a port, which we already defined. If you remember, the port was actually passed in from our config file. And then once that is done, we log, like Express server is listening on, and then the URL of where our server is running. Once that's done, we just resolve the promise because everything went fine and dandy, and we're done. That starts our server. And if things went wrong, we just make sure to disconnect from our database with Mongoose, and also log whatever error occurred while trying to connect to the database. And then the stop server, thankfully, is much easier on the eyes, because to stop it, all you have to do is do mongoose.disconnect from the database first. And then if that goes well, then you run server.close. Now, this part might seem odd, like server.close, where does server even come from? That's a good question. Server actually comes from this global we defined on line 16. But notice how when I start my server successfully, I store a reference to my running server inside of server, so that I can just call server.close once I'm ready to shut it down. And if everything goes without problems, it just logs Express server stopped, and we're done. So this is basically our super basic logic. Now let me just add some dummy content to my test HTML file. So here's a test page, just because we want to test if it works. So let's just create a simple page called Hello World. And notice how when I saved it, it automatically indented it. That's really nice. I really like that. That's because of the feature we enabled at the start. Now that that's set up, it's time to run our server to verify it's working as expected. So I'm going to write a new file called start.js. This is what I'm going to use to start my server. So instead of start, I'm literally just going to do this. I'm going to require my app.server. So as you can see, this is my app.server. Let's put this side by side. So here I require my app.server. So it's this app/server. And I'm requiring this object. And then I'm extracting the start server from it. And then that allows me to basically start the server. So that's set up. Now let's run this. So in order to run this, we can do two things. We could open the terminal. So you can toggle or integrate a terminal and do node start.js. And I can do that. I can just do node start.js. But a better way is to have our package.json be able to start it for us. So let's do that right now. Let's add a script for start. And let's make it run node start.js. As you can see here, if I now do npm start, that should work. There we go. And if I click on this link, you should see, I guess it's not really opening it. Let's just navigate there directly. There we go. So that looks like a success to me. Error not found. Error not found, that makes sense because we didn't add basically any route handling at all. We just used the default, which throws an error because there is nothing listening to this route. But if we were to type the name of one of the files in public, so let's do that right now. Let's add test.html. You can see that works. So far so good. We are actually running as expected. And you know what? Before we continue, let me just super quickly show you how to run this in debug mode configuration. So I'm going to run this in a way that you can actually stop and see the code running line by line. So if you go to the VS Code's debug panel, click on the gear icon, and that will allow you to create a new VS Code debug configuration. Just select Node if you're prompted. And there we go. That's pretty much it. So here you can see type, node, request launch, name launch program. And my program is actually wrong. I do not want to launch ESLint.js file. I want to launch start.js. So there we go. Let's also make this a bit more explicit. Let's call it debug server. And once that is set up, I can actually add a breakpoint like here. And if I click on play on start server, you will see that this time, instead of running it, I actually press on the play button, and VS Code is going to start the server for me. And then that allows me to use the interactive debugger to run my server line by line to verify that everything is working as expected. Like you can run the server line by line, you can see all the variables in existence, you can see the call stack for all the functions that were called up until this point in time, hover on top of variables to see what value they have, if they already ran, as you can see right here. And finally, you can actually type JavaScript in the debug console. Like you can do 1 + 1, you can do bar x equals 2, then x + 3, or just plain out enter variables from the running JavaScript scope. So it's really handy, and this is what you should be doing if you ever get into server trouble, all right? So yeah, I think that's about enough for that super quick how to run the project from VS Code introduction. Now it's time to actually start building something useful. So we're going to begin with our user authentication, because I honestly think that authentication is probably the hardest part about coding a server side. So I think it makes sense to just start with that, because it's going to be just so much more of a cakewalk if we finish that. So let's set a new folder for user, which is where our auth stuff is going to live in. And we want to create first a model for our users. So what do our users are going to look like? So if we look at our user models, you will see that it's empty, of course. So we're going to need three things. We're going to need Mongoose for connecting to MongoDB. We're going to need Joy for validating data, as you will learn soon, and Decrypt for encrypting the passwords, because you never want to store real passwords. Now, this is what my basically a structure for each user looks like. Yours may vary, but this is what I chose mine to be. So I just want each user to have a name, an email, a username, and a password, and they're of course all required fields. You almost never should forget that's a super important serialized method, and here I think it's more important than ever. And the answer is super simple. Notice how I am not sending back the password. Why? Because you don't ever want to send the user the password, even if it's an encrypted password. That's super dangerous and a huge security issue. So notice how my serialized method just returns a cleaner object with no password inside of it. So it's super important we always have that serialized method. And then we're going to add two more methods to our object, which we're going to use when we get to the authenticating part. So one is hash password, which basically receives a password string and converts it to an encrypted password, as you will see very soon once we encrypt our first one. And finally, we have a validate password method, because once we encrypt it, we cannot know what the original was. It's impossible. That's the entire point here. So instead of figuring out what the encrypted value is, we basically re-encrypt the same password and see if it matches the currently stored password. And finally, validation. Validation of data is kind of a big thing in security, but it's usually very hard to do. And that is why I like to rely on Joy. Joy makes it super easy to validate data. So you will notice that I can pass Joy basically an object, and it will check that this object has the keys name, username, password, and email. And then I use Joy to do many checks, like Joy is a string of minimum 1 character, is trimmed, and then password is a string of minimum 8 characters and max 30, and is trimmed. So you can do so many checks. And even email, like Joy automatically has an email function, which makes sure you actually sent an email. So it's honestly fantastic. If you want to learn more about Joy and all the validations it can do, just check the included link. And that's it. We have everything we need for our model. So let's just basically create our MongoDB model, as you can see here. So that's our user model. And we just export, or basically user model and or user Joy schema. And that's about it. We pretty much are set. I believe it is now time to basically add the authentication strategies, because that's something we're going to need very, very, very soon. So basically, because we're going to use authentication via Passport, you want to basically rely on something that does it for you. So it's definitely quite a bit easier. So in that sense, we basically want to initialize Passport as well. So let's do that right now. Let's create a new auth folder. So here's our auth folder. And instead of auth, we're going to have two things. We're going to have the Auth Strategies and the Auth Router, which we'll get to in a sec. So our Auth Strategy is basically kind of a critical part of authentication. And basically, our Auth Strategy just means how Passport is going to check if a user is actually logged in or not. So our Auth Strategies are going to look kind of a bit like this. So we first import our user model, as you can see here. So here we import from the user folder /user.model, and we import the config. Now, there's two big strategies you always want to have. So one is the local strategy, and the other is the JWT strategy. So the local one is going to be used every time you try to basically access an endpoint using a user and password combination, while the Gwt strategy will be used every time the user sends in a JSON Web Token, which is basically just like an ID card they can use to quickly access a protected resource. So yeah, a quick comment. My audio cuts in and out. Oh, that is kind of a bit of an issue. Let me just quickly check if there's anything I can do. Maybe I have something uploading. Let me just see if I can disable that. Didn't notice I was uploading. Let me know if you still hear audio issues, please, because that is a big issue. Yeah, I think that hopefully should be fixed now. I hope. Okay, let's continue. So, going back to this, here we have our local strategy. So our local strategy, as we mentioned, is what defines if the user is actually authenticated. So here, what it's doing is we first use MongoDB to search the user database and see if we can find the user with that username. If we can, then basically that just means that that username that the user tried to use doesn't exist. So we throw an error if that happens. Then if that doesn't happen, we validate the user's password because we know that user exists. We now need to validate the password. If it isn't valid, we also throw an error saying incorrect username and password. And if everything works as expected, we run passport verify, which is a callback that Passport receives. And this is what makes sure that we're actually allowed access. Now, passport verify, this is something that's called the done callback, is not very easy to understand. It's kind of tricky. I don't like it either, but it's something you kind of have to deal with. And at least they do a reasonably good job of teaching you how to use it and why you have to pass null, why you have to pass the user, why you have to pass false. They explain all of it here. So feel free to check out the link if you're interested in that. And then finally, we add our Gwt strategy, which is a bit simpler. And basically, this just checks our JSON Web Token and if it's a valid JSON Web Token. And once we have two strategies, now it's just a matter of doing the passport.authenticate method. And this literally just creates a piece of middleware we can use on all our endpoints. And thankfully, this is all we need. This is all you need to enable authentication on your endpoints. So I export all of this because I will be using some of this in a second. So once I have my authentication strategy, you want to add a login endpoint and an endpoint to create users, of course. So let's do that right now. So let's add a new Auth Router. So here is the Auth Router.js. And thankfully, this one's going to be a bit simpler. So for dependencies, we only need Express, of course, to create a router. We need a JSON Web Token to create and issue JSON Web Tokens. And notice how we import our local passport middleware and a JSON Web Token passport middleware. We will be using both of them very, very soon. Now, I create my Auth Router function. Basically, this is just a simple router. And I'm going to create a function helper, because I will be using this quite a bit, called create JSON Web Token. And it receives a user that it will then encrypt into a JSON Web Token that we can issue out to the user so they can just quickly use this as their ID card to access protected endpoints. Once this is set up, now it's just a matter of writing the endpoints, which at least for this one are going to be super, super simple. I really like how clean they end up looking. So,
say that again?
Yeah, so basically here all we did is we created a utility function to create JSON Web Tokens. These are just going to be like an ID card that the user can use to like access protected endpoints instead of having to type his username and password every single time, which is not only super tedious, but super insecure. So that is set up. Now we have our two endpoints. So one is going to be to log in, and one is going to be to refresh their web token, because JSON Web Tokens have an expiration date. That's very important here. So our login endpoint, notice how it uses our local passport middleware. So because it uses this piece of middleware, if it gets to line 20, it means that this user is in fact valid. So basically, this did all the work for us. This already made sure that the user trying to log in is valid. So it made the work super easy for us. Now it's just a matter of accessing the user from the request. This is thankfully stored by Passport. The reason why we can do request.user every time we use middleware is because of Passport again. So Passport automatically attaches the user information into request.user. Then we serialize it, which just basically, if you remember the serialized part of it, it returned a clean object with no password inside of it. So it's very important that we serialize it. You do not want to create a JSON Web Token with the passport inside of it. That's very dangerous. So we serialize it, and then we create a JSON Web Token with the user. Once we have our token, we respond to the user that tried to log in with a JSON saying, hey, here is your JSON Web Token. Everything went fine. And here is the user in case you need it, like the user's email, username, and full name. So yeah, that's our login endpoint. And the refresh is almost identical if you think about it. Like it's the same middleware, like inner workings, but this one's the JWT one, because unlike the login one, refresh doesn't leave username and password. Refresh receives a JSON Web Token that the user wants to renew. So that's exactly what we do here. We extract the user from it, and then we renew it, as you can see right here. And that's it. We have everything we need for authentication. We still don't have how to add new users, which is kind of an important thing. So let's do that right now, because that might be the biggest challenge. And the reason is because user creation is kind of a tricky part, because you need to validate all the information of the user is correct. But at least if we get through this, then the final stage, which is adding like actual nodes, is going to be a cakewalk, because it's just more of the same, just more routes and more models. So let's add our user router. And as usual, we want to import the typical boilerplate, which is Express and Joy. We want to import our config file to get the status codes. And we want to import a user model. And this time we will be using the user very, very intensively. So let's create our user model. So you can see our user model right here. User router. And now it's time to write the create new user endpoint. So I'm just going to add it in. So please bear with me, because this might look very scary at first. So that's a ton of code, but trust me, it's not. It's actually quite simple once we break it down. So once you try to create a new user, you're going to receive inside of that request.body the parameters that the user passed in. The reason why you can do this is just super important that you know why we can do request.body and all the data he sends. That is thanks to this piece of middleware. This is super important that you use. Otherwise, you will not be able to just do request.body magically anywhere in your app. So this is what does all the hard work for us. With that said, we create a new user object that's going to be saved into the database. Now, normally we would have to validate everything step by step. At least that's the way I think Thinkful's current curriculum material does it. But that's too much work if you ask me. That's like 50 lines of code for multiple types of validation. And I don't know, I felt like I could save you guys the trouble, so we just use Joy. So here we do joy.validate, and then you pass it the new user object, which we defined here, and we validate it against the user Joy schema, as you can see right here. So this user Joy schema, if we open it, it's this user Joy schema we defined. So basically, our user Joy schema is the checks we're going to make on our data. So it's going to check that the name is a string of one character at least, is trimmed with no spaces before or after it. It's going to check that the email is actually an email. It's going to check that all the required fields are present, etc. So it's a really easy way to do all the validations we need in one go. So we do Joy validation. Then validation returns an object which is either empty if no errors occurred, but if it did have an error, then it has an error property. So here we do if validation has an error property, then, and in this case we return a server status code response saying HTTP status code .bad request. And then we respond with a .json saying the error and the actual validation .error, so that the front end can figure out what went wrong. So that's it. 3 lines of code, and we have all the validation set up. It's fantastic. So now it's time to actually create the user. Now, this is where things can also sometimes go wrong. you need to always check if another user doesn't already exist. So for that, I like to use the find one MongoDB operator, which you can always learn about more in all the links I added. Like if you are curious on how, for example, find one works, you can just copy this, paste it in Chrome, and learn all you need to learn about it right here. So it's really handy, as you can see here. So here it tells you how to use it, what it returns, and multiple use cases for it. So really handy. Now, here, the check I like to do very often is I try to find a user that has that or a condition. So it checks if this user has the currently submitted newuser.email or the currently submitted newuser.username. So that way, no two users can have the same username or email. So I make this check super quick. Then, if a user is returned, that's a bad thing because it means a username already exists. So if that's the case, I return a status code of bad request and the JSON saying database error, a user with that username or email combination already exists. So that's that. If nothing happens with this user, then we start storing the actual user. So before we store it, we hash the user's password. And then once it's hashed, we basically replace the new user's password with a password hash because we never want to store the real password. Remember, we always store the hash. And then once that works, we do user.create, and that's it. User.create creates the actual user in our database. And then if it is successful, we respond with a status code of created, and then with a JSON of the actual created user in its serialized form. So we don't return the password. And then in the catch block, if an error is returned, we just return the usual internal server error, and then a JSON of the actual error message. So yeah, that's pretty much it. Authentication is pretty much done. So let's implement that on our server now. So the next step for our server to actually implement authentication is a few things. So you want to import both routers. So let's do that right now. So let's import the Auth Router and the user router. And also we want to import our passport strategies. So let's import them right now. So here are our passport strategies. And then it is time to actually implement Passport. So to do that, that's super easy, thankfully. It's literally 2 lines of code. So passport.use and passport, basically passport.use twice. And then you implement the local strategy and the Gwt strategy. That's it. That's all you need for Passport to actually officially use them. So yeah, that's about it as far as authentication goes. This should already allow us to create users. So let's give it a test run. I'm going to run my server. So let's run our server right now. And let's, I almost forgot. I forgot a super important part, which is actually using my server, actually using my routes, which I just created. So I imported them, but I didn't use them. So that's something very important we absolutely need to fix. So let's stop our server. Let's add our routes. So we do app.use. And then all calls that get made to /API/auth get redirected to Auth Router. And all calls made to API/user get redirected to user router. So yeah, now let's click play on that and see what happens. I'm really curious if this will work. Okay, so we are already getting an error. Let's see what we missed. I think we missed something really simple. So it's a router index application. Where is our function? There we go. Server.js line 30. So this is the fella that crashed on us. Oh, it's an error. Has no property user router. Oh, let's check out user router. Whoops, very big mistake. We forgot to export the router. That's a very big rookie mistake. So let me fix that right now. So let's just do at the end of this file, model.exports user router. And let's try restarting our server again. And hope for the best, because we really want this to work. I'm not very, I'm human, so I'm capable of making mistakes. So let's see if I got this right on the first try. So let's do post, new user. I'm going to try to create this user in my database. I want you to show you how right now in my just jotted database, I have no users whatsoever. So let's try to create a user and see if it crashes. Oh, it worked. Nice. That's a nice surprise. So we can see that it returned that created user's new database Mongo ID, as well as the name, email, and username. And to prove it, we can just refresh the user's database, and you can see that we now have a user. And notice how the password field looks. This is why we encrypt passwords. Basically, when you encrypt them, instead of storing the real password, it stores a hash of the password, which is basically not impossible to crack, even by modern supercomputers. So that way, even if your database gets stolen, no passwords are compromised. So yeah, that's really handy. Now, that's working. Let's try to log in to our endpoint. So let's do a new login. So I'm going to open the Auth login endpoint. I'm going to basically copy this into my request body. So here's my request body. This time I only need my username and password, so I can get rid of this. Notice how I make the request of type raw and JSON. That's super important, otherwise it's not going to work. And also make sure the methods are correct according to your server. So that is set up. Let's try to send it. And there we go, that works. We're actually getting a JSON web token we can use, and the actual user information. So that's very handy. Everything seems to be working as expected. We can now create new users, and they can log into our database. So that's really cool. Now, we have the final task, which is adding basically the to-dos on our database. Thankfully, that's a relatively simple task with all the code we have now. So now all we need to do is create our Node folder. So we're going to start a new folder called Node to store everything Node related inside of it. And then inside of it, I'm going to add my Node model. Yes. So the Node model is going to look a lot like the user model in that it has all the typical methods. So it has its schema, it has the serialize method, it has the join validation, which we use to make sure it is a valid node, and it creates the model. The only notable differences, which I want to point out here, are number one, the user. So I want you to notice how the user, instead of being type string or type boolean, I make it of type mongoose schema types object ID. And the reason why I like to do that is so that it ties each node with a user. And that's very important here. So I like to do that so that we can just fetch all the nodes from that user automatically. Also, notice how when I serialize a node, because some nodes will have an actual user object inside of it, I want to serialize it if I can. So the reason why I have to do this check is because sometimes the user will just look like a mongoose ID. So a mongoose ID does not have a serialize method. Only after I populate the object, which you will see very soon, can I serialize it. So I make sure to serialize it. Otherwise, when I return this object, user is going to include all of this information, including the password. That's super dangerous. Remember that. So I serialize it if possible. And yeah, that's about it. It's actually simpler than the user object. There's no encrypt password, compare password, hash password, none of that nonsense. So it's much easier in that sense. And as far as the endpoints, let's begin with our Node router. So let's do node.router.js. And let's begin with the usual boilerplate. So we're going to need a few things as usual. So we're going to need Express, of course, to create the router. We're going to create the Node router from Express.router. We're going to use Joy for validation. We're going to use our HTTP status codes for responding them. We're going to use this time, because these endpoints can only be used once you're logged in, we're only going to use the JSON Web Token Passport middleware. That basically parses the Passport JSON Web Token automatically for us. And finally, the node. That super important node, which is our way to communicate with the database. And the node join schema, which we'll use once we create new nodes. So let's begin with that. Let's begin with the endpoint to create a new node. So let's add that endpoint really quick. So basically, it looks quite a lot like the new user endpoint, because it is. Like, this is the nice thing about coding, especially server side. A lot of the procedures are the same. Like actually, a lot of server-side apps look very much the same, in that the only difference is like the data model, or the different structure of data. But other than that, the process is nearly the same. creating a new node object, validating that the data inside the new node is correct using joy. And then if an error occurs, then just throw an error. And then if this is successful, because nodes aren't users, we do not need to do the typical check if our new node doesn't already exist. We don't need to do that. We don't care if a new node with the same title or content already exists. We don't care. So we can just go straight ahead and do node.create, and we're done. That creates basically a new node. And I actually made a typo here, which I should have corrected before, so I'm just going to correct that super quick. So excuse me for that. So created node. There we go. Whoops. There we go. So I receive a created node object, and then I respond with the status code of created because it was successful, and a JSON of the created node in its serialized form. And if an error occurs, I catch it and throw it to the user. So the usual. That's it up. Now let us retrieve our user nodes. So let's add the endpoint to retrieve a user's nodes, because what's the point of creating stuff if we can't fetch them, right? So let's add that in. So this one thankfully is much easier to use. So as usual, I use my JSON Web Token Passport middleware to verify that the user is actually logged in. Now, thanks to this middleware I now have access to the user instead of the request. This is Passport at work. So this is, again, Passport making our lives easy. So because the JSON Web Token Passport middleware automatically extracts the user from the JSON Web Token, you can do request.user.id. And then all I do is I do node.find, and this allows me to search for nodes that have a matching user. So this allows me so that this endpoint can only retrieve nodes from the currently logged in user, which is really handy. Like, it saves us a lot of work, to be honest. Now that is set up, I do this method called populate, which is super handy. And the reason why I like to run populate is because you will see in a second, once I show you what a node looks like, the user is going to look like this ID. Like when you check the nodes database, it's going to have a user property with something that says object ID and some random number. That's not very helpful. That's just a random number. So if you do .populate, it's going to actually search the user database and inject the actual user document, the actual user object from the user's collection into the node document. So it's really handy for us to just return the full thing to the user. And then once that is successful, I then get the nodes and respond to the user with a status code of OK and a JSON, where this part is what I have to recognize trips up quite a few of my students, and I don't blame him. I think overall array syntax with arrow functions tripped me up a lot when I was first learning things. So this is all we're doing here is because nodes will be an array of nodes with a lot of non-clean data. Like notice this _b. This is a MongoDB private thing. Like the front end should never know about this private information. So serialize gets rid of it. However, because this is an array, we cannot just do array.serialize. That doesn't work. Serialize only works on objects. So what I do here is I do nodes.map, which returns a new array. And the way this array is returned is that every node inside of my nodes array gets run into this function, and then it returns its serialized form for each one. So that way I end up with an array of automatically serialized nodes. So it's very handy. And if I get an error, the usual, I throw an error and the JSON error format as well. So yeah, that's pretty much it. Now, time to also add a new endpoint to retrieve one user node. So because this is something you will be using once you try to create, maybe when you add a node, you might want to click on a node. So for example, if we go to my app running right here, once you, it's not loaded yet, but once it loads, basically when you click on a node, you want to view the node's details. So for that, we write a new endpoint. So yeah, this endpoint, so that when you click on this node, it allows you to using just the ID to fetch the details of that node. So I just added that endpoint right here. So the difference here is that this is a parametrized endpoint. And what that allows me to do is so that my requests, so if I refresh this page, you can see that my request looks a bit like this. Let me find it. There we go. So my request is API/node, and then whatever gets inserted at this point gets stored into this node ID variable, which you can access by doing request.params. So it's really handy. And what that allows me to do is run Mongoose's find by ID method, which finds a single document by its ID field. So I just receive the node ID in the params. I then search any node which matches that ID. I again populate the user object, and then I return the found node. So it's really simple. All thanks again to that we just returned the node ID magically. And also notice how I could have made this a protected endpoint, but I wasn't really sure where I was first building this, but I could actually make it. But yeah, here I just didn't add it because it wasn't really needed. Now, as far as remove node by ID, that's also very important. Like, we need the ability to delete nodes. So let's add that right now. So let's add our ability to delete nodes. So here it is. So this is basically our delete router. So in order to delete a node, you also receive the node ID. You receive the JSON Web Token Passport middleware because, of course, you want to make sure he is logged in and you're not just trying to randomly delete nodes. And then, again, we just do node and then use the Mongoose method, find by ID and delete. So this command basically deletes an item by its ID field. So again, we extract the node ID from the endpoint. And if it is successful, this is a bit different because when you delete something, no response is given. You just delete it. So in this case, I respond a status code of no content. And then because I have no data to send back, I don't send JSON. I do just .end. This part is super important. I've seen a lot of mistakes being made by even me, where basically you forget to add the .end and then the server never ends. Like the request never returns to the user. You need to do .end. Otherwise, Express doesn't know that you're done like handling data. Like, you can return this to the user now. So yeah, that's our remove node by ID endpoint. And now we have our what would be the update node by ID. So the update node by ID is going to be something like this. So update node is kind of similar to create, but at the same time it's not. So it's similar in that you also basically create a node to update object with the properties like title and content. You validate the data as well to make sure that they're present. And basically, instead of creating it, you have to do it a kind of different way. So instead of just creating it, because you do pass the node to update, like the actual object, you need to tell it what node you want to update. And that's what we need the node ID for. Basically, the way this Mongoose method works is it receives a node ID or an object ID, and once it finds it, it updates it using the actual object that you provide. So yeah, other than that, it's kind of pretty much the same as the create method. And once that's set up, we respond with a status code of no content because it was an update, there was no content, and we end the request right there. And now we are pretty much done. So let us export our node router, as you can see here. So we export the node router. Also, you might have already noticed, I like to name my routers explicitly. I don't like to, there's people that like to do just router. I'm not a fan of that because once you learn and you work in very large code bases, it's super easy to get lost. So the more visual indicators I can get that tell me where I am, the better. So here, even if I don't see the top bar, I just read node router and immediately think, oh, cool, I'm on the node router. So that's why I like to be very explicit. It saves me so much more time on the long run. So yeah, that's my node router. Let us include that into the server because I believe we're pretty much done. So let's add our node router as a dependency. So here it is. And let us also make sure we add the node router to our endpoint. So let's add it to the request handling. And we're done. Let us stop the server and restart it one more time to basically test our endpoint because what good would this be if we don't test it just to make sure it works as expected? and see how many errors I made this time. So yeah, kind of a nervous laugh there. So there we go, that's running. So we have our successfully logged in user here, so we can use this JSON Web Token to try to create a node. So right now we have no nodes, as you can see here. So if I try to fetch nodes, there's no nodes. So I'm going to first create a node. So here's my API to create a node. This is my test node. Now this will not work unless you pass in basically your JSON Web Token. So to do that via Postman, you go to authorization, you go to bearer token, and here you paste your JSON Web Token. So here I'm pasting it right here, like copy pasting it. Make sure it's bearer token. And once that's set up, I should be able to click send and hoping for the best. There we go, success. So we get an ID, a linked user ID, as well as a title, content, created date, and update date. And to verify that, let's open the nodes, and there we go. Here's our first node. Let's try to create a new one, just because we want two of them for the heck of it. So let's create my second node, and let's do send. We should now have two nodes, I hope. So let's do nodes. There we go. Yeah, that's two nodes. Yeah, that works. Now let's try to retrieve all the nodes of that user. So let's click on retrieve all nodes. Now before we do this, let's make sure we do have our JSON Web Token copied over, because we will be needing this for all our requests. So let's do retrieve user nodes. And this is just a get to API/node. And my token, I'm going to paste in my JSON Web Token, as you can see right here, and click send. And there we go. Those are the nodes from the user. Now how about we try to delete a node, because that's also important as well. So let's try to go to the delete node endpoint. Let us again paste our authorization bearer token here. And now this time we're going to delete, let's delete the first node. So this is the first node. Let's copy that. Let's paste it here, because this is the node we want to delete. And let's click on send. And that's okay, that's good. It looks like that might look like an error at first, but that's why you see the status code, no content. So that means the server successfully processed the request, but is not returning any content. And finally, the update endpoint, which might be kind of odd to use. So the update, again, we copy over our header token, paste it. And we want to, this time, let's retrieve all user nodes to verify. There we go. The first node was deleted. We're going to update this node, the second node we created, and we're going to update both things like the title and the content. So let's copy both into our object. So here is our request body. Now I'm going, oh, there we go. That's already done. So I'm going to name it modified node. And for my content, I'm also going to change it to modified content. There we go. I'm going to click on send. And again, no content, which that's good. That means it was processed as expected. If I click send, we should see a title of modified node and a content of modified content. Woo, that was a lot. Holy crap, we made it within the hour, barely. So that's much better time than last time. We definitely went quite a bit over the hours. So yeah, I'm going to stop the recording right now. So let me click on the stop record button right now, and